Welcome to the Grid Mod Pod, brought to you by AEIC. In this podcast, you'll hear from the utility industry's top operations leaders on how their companies are working to modernize and improve our ever-evolving power grid. Thanks for joining us.
Welcome back to the Grid Mod Pod, where we continue to explore really the systems, the people, and ideas shaping the modernization of our electric grid. So today's conversation brings us into a space that I think has and could be quite technical, but really human in regards to transformations and innovation and kind of what happens when engineering meets collaboration. So we're joined with Marco Sanchez, the CEO of Stella Energy, a company known for developing advanced cooling systems. And if you're in this space, you know that's important right now. And really that integrated energy solutions. So I think this is a timely conversation with the technology that's ever rapidly changing and we need to embrace. So with your journey, I look forward to sharing with the audience what you're up to and kind of how it fits into the larger picture. So with that, I'll throw it over to you, Marco, to introduce yourself and then we'll get started.
Thank you, Elizabeth. I'm very excited to be part of this forum. And, I've always followed your podcast, so finally get to be in one. So that's great. So Marco Sanchez, I'm actually a chief advisory officer of Stellar Energy. Spent 15 years with an power generation OEM. And then 3 years ago, the owners of Stellar Energy called me to help them scale. And I served as their CEO for close to 2.5 years. Now, as a board member, I am very happy to say that Stellar Energy continues to grow and continues to be very focused on the power generation and LNG market. So I'll just kind of jump in a little bit into Stellar Energy and the genesis of the company and its focus. It fit really well with some of the AEIC programs, some of the conferences, and why it was crucial for us to be part of that cohort. So Stellar Energy at its core is an integrated engineering company with its own manufacturing. And it all started with district cooling in the Middle East back in the 2000s, late 90s, where, there was very similar situation to what we have today. There was a scarcity of gas turbines and power generation equipment. And to put it in simple terms, the technology of turbine inlet air chilling and thermal energy storage really came to become a hero in that region because there was a large need for power generation, and the lead times for what we know today, transformers, switch gears, gas turbines, and mainly people, was lacking because there was a very high demand for power, and very similar to what we're seeing today.
Right. I was going to say it sounds very similar. And that was early 2000s, you stated?
Yes, correct.
Yeah.
So obviously there was big boom, and Saudi Arabia, the Middle East was developing their infrastructure, and they were looking to build as quickly as possible. Some of the initial projects were in Dubai, in Riyadh, and inlet air chilling, not to simplify too much, basically what it does is it brings to turbines what we call winter in July. So when gas turbines are designed, the ultimate condition that a gas turbine looks for is 45 degrees F or 18 degrees C. And what that does is that allows them to have its maximum performance. So what we do, and it's a very large civil engineering project, and it requires an EPC to be part of the project, an engineering, procurement, and construction company. But the magic of it, or the beauty of it, is that you can recover the lost power during the hot and long summers that now we have in many areas in the US and around the world. And you can recover up to 20 to 25% of the output you lose during that period. Not to get too technical, but there's a big difference between evap cooling, wet compression, and inlet air chilling. Evap cooling and wet compression, they help bring the wet bulb temperature down from, let's say, 100 degrees in Texas or in Florida or in Arizona down to lower conditions. And they really address humidity. For inlet air chilling, we're taking dry bulb temperature down. On a case study that we're very proud of being successful on as an EPC, we presented and during 2 AEIC conferences in the last 2 years is in Phoenix, Arizona. We successfully commissioned 2 systems at Red Hawk and Sundance, where we were able to recover close to 300 megawatts of power. Where, in Arizona, they've seen extreme summers where they've seen over 118 degrees F for months. So what we did is, as an EPC, we guaranteed that we were going to bring down the temperature from 108 degrees down to 50. And basically what that did is recover all this lost output that the gas turbine had. Stellar Energy was not always an EPC at some of the early projects in the early 2000s and late 90s. And, we have about 150 plus systems around the world. We were a subcontractor to EPCs. APS was one of our first and largest successful EPC projects. We are looking into working on with other utilities, and we're in the process of finalizing contracts for new installations. The key of the project is that you're able to recover the output in a lot less time that you need to when you put in a simple cycle gas turbine. So in less than 36 months, you can have an installation of inlet air chilling. And depending on the scope, it can be as low as 24 months. Now, there is another component of the project that Stellar Energy focuses on, and it's thermal energy storage. And that allows for the project to be extremely sustainable and ensure that we have a redundant system, obviously taking care of water. The system heavily needs chillers and pumps and compressors. So by using a thermal energy storage, you're able to optimize the system basically like a thermal battery, which qualifies for an IRA credit. That has captivated a lot of attention because obviously if you can get power in a lot less than 5 years and you're able to capitalize the project as a utility, it's a very good and different way to be able to get power on the ground. We call it, powering when you need it the most, power now, and obviously you need it in the summer. So it's an ability to have winter in July for these gas turbines, and it's heavily focused on where a lot of these data centers are going, right? Data centers are going to New Mexico, Texas, Arizona, and those are regions that, they're hitting a bottleneck of power. You don't need a full environmental permit because you keep net efficiency. It's net, carbon dioxide is net. So you're not really adding extra megawatts. You're just recovering the megawatts that you lost during for ambient conditions.
So, okay. So just spelling it out for our listeners, and also a lot of our listeners are looking to be a part of our industry as well as learning, all of the components. And I'll say, you said EPC, which means engineer, procure, construct, which is a skill set, a capability, a domain that our industry, aka the electric utility space, have really adopted over the last 20 years in regards to really, I think, I would like to maybe rephrase it, but staff augmentation inside the utility space, enabling organizations to really become SMEs in the engineering and design space that can then support the internal design engineers, as well as support the procurement, which is a whole world in itself that I think, we lose track of when we're trying to solve the problems that continue to percolate to the top of our industry. And then last, that augmentation to be able to actually have the staff, the resources to construct. And so what you said is, when you originated, you had a solution to a problem, which was to meet the expedited need. You actually had a solution to multiple problems, which I'm actually teaching a course here this fall, and I spoke to the students about this. They want to be a part of the industry and they want to help. Like, what we need to do as, I think, beings is actually solve for problems that exist instead of creating solutions and looking for a problem. So what I heard is actually you guys solved three. Is like, you need the generation quickly, and you also needed to offset the inefficiencies that were occurring based on the extreme heats, and not just the wet heat, but this dry heat, which is like a whole, that just opened my world. I need to go figure that one out. And then lastly is, with everything happening now in our space where we need more energy yesterday than ever before in our civilization, the concept of this thermal energy. So creating a way to store energy for another time, which is something I think a lot of our listeners understand, is the energy storage realm, and like, who are the solution providers. So, I mean, we can pick apart all three, but I just want to kind of level set, what you just rattled off there was solving three emergent problems with an evolution and adoption of a said particular technology that had one goal and now can facilitate many. Is that what I'm hearing, or you can clarify?
You're right on it. And I think at its core, it's like you said, it's all about collaboration. And this was truly an integration between folks that were experts in cooling, advanced cooling solutions. The parent company, the former parent company of Stellar Energy, was very focused on building, heavy district cooling systems and leveraging cooling and cooling technologies and the experience that some of the folks that came with in the beginning of Stellar Energy was critical. They were not experts in power, but they were experts in cooling, but they were experts in building infrastructure for cooling systems. So with that brought, a lot of partners to our ecosystems that we didn't have them in power before. So we buy chillers from Train, from JCI, from Carrier. We buy heat exchangers from Alfa Laval and Kelvin, and pumps from different providers and valves from different providers, that we were able to integrate systems and solutions that were, more integrated in universities and hospitals and buildings, and put in a very industrial setting. And for that, we needed to harden those systems, right? Those systems were not used to operating 24/7. So we basically built this superstar team of experts from the LNG industry, from the cooling industry, from EPCs, to make sure that we were not just saying, hey, include this as a power augmentation technology, because that's really not all it is. I think to your point, we managed to solve something very critical for the OEMs and for the operators. And I know you're big on reliability. So what happens to a gas turbine when when it is operating at the same ambient temperature, 50 degrees versus 100 degrees, is the work that it's doing is obviously a lot easier to move air that is not as dense in the compressor. So you are able to optimize the operational cycle and the outages for the gas turbines. And because I was part of an OEM and I ran an LTSA group, and we ran a lot of systems to try to optimize and minimize unnecessary outages. The game is, availability, availability, availability. So a lot of the topics that during like 10 over a decade, I remember working with the AEIC members on, is how can you extend the maintenance intervals of gas turbines, which early on when gas turbines get introduced, they're about 12,000 hours. And today, we're up to 36,000 hours in some cases on some of the frames. Well, in order for you to not have any outages on these gas turbines during 3 years, because most of these gas turbines, you want to operate them at 8,000 hours a year, you need to have the best ambient conditions. So when you are able to optimize the inlet conditions, and we call it T2 or T2 temperature, to 50 degrees, these gas turbines operate in their optimal design parameter. So not only they get more output, but they also are a lot more reliable.
You threw a couple more there our way. So just, I guess they say, tell them what you're going to tell them, and then tell them again what you just told them. So I think you went 3 shovels deep on when collaborating with other SMEs, this space of greater ideas are really born from constraints. So having these awarenesses of what others are enduring from engaging with those that use the actual product, allowed you to really think through how to adopt and innovate and then drive the solution. So I guess that's kind of what I heard.
No, and I think as listening, right, to some feedback, we did, at times we're from utilities, from AIC customers and vendors, they would tell us, hey, this is why it's not that simple to put inlet air chilling next year or in 2 years. We mold our project solution and our teams in a way that it's not that we're just trying to make a commercial sale. It really needed to solve different problems, and we needed to guarantee that. And with that comes contractual guarantees with liquidated damages, and you're truly, supporting and making sure that you're guaranteeing the performance of the system and the schedule of the project. I think other examples are as we were in a journey of growing on the power generation and LNG, the hyperscalers came to us because they knew we were buying chillers from some of the chiller OEMs. And they've asked us if we could help them with their modular expansion of cooling. And through a very rapid scaling and expansion, we've helped them scale how much we could do of cooling. And today we're, one of the three biggest integrators of cooling systems for the largest hyperscalers. We have a factory in Jacksonville, Florida, that it's about 600,000 square feet. We're going to announce another factory very, very soon in Texas. And that manufacturing capabilities and our engineering experience is what allowed us to scale quickly. And I think that's just given us another side that we presented in one of the conferences in DC of how we're now partnered with the hyperscalers to help them deploy what we call digital infrastructure for power. So now we're looking at how do we help, both utilities and different players in the power market to integrate inlet air chilling and data center cooling in their assets, because it doesn't make sense for us to buy chillers for the data center and chillers for the power plant when we know both of them are going to be located in the same location.
So, you brought up hyperscalers, and for our listeners, there's this world that's occurring where, the electric utilities, have formulated these large machines that deliver power to all customers within their geographical space. And they've been regulated with a significant amount of mandates and or technical standards to ensure safe, reliable, affordable power. And so in essence, how, when we as individuals who, turn on our lights, we really only think about the electric utilities when our lights are off or when we're moving. And so there's a whole ecosystem. I'm getting somewhere with this for our listeners. And so here we are as an industry, which I like to say I'm also the grid historian for you all, but, the original 80 years, maybe 70, utilities designed, built, manufactured the majority of these assets that we all come to love to serve our very reliable power. And then it wasn't until really like the 70s, 80s where there's this whole world of manufacturing and this whole other vendor space where like we gave over that expertise and that due diligence to craft and manufacture the actual assets we need to maintain the grid. And so when we think about now where we're headed, right, the vendors that have all showed up and delivered these large, massive pieces of machinery to maintain our power grid, there's a new customer in town. It isn't the individual 330 million-ish, let's say, sitting in the States that are requiring these assets to be procured and constructed to serve power. We now have these customers that are known to us as hyperscalers. And so just so I'm doing less talking, what is a hyperscaler when you say hyperscaler compared to maybe the other? And
I
then
love how you
have,
asked me that.
and I was, then I'm going to ask a
I
question.
came from a world of OEMs, 15 years dealing with utilities, independent power producers, municipalities, and this was a Japanese OEM that had business around the world. We dealt with governments, and as I joined Stellar Energy, I got introduced to this world of hyperscalers, and I kind of had the same question, like what does qualify as a hyperscaler? And the way that I could describe it best is truly someone that's dealing across the board, not just building the infrastructure for data centers or owns their cloud space. They're both on the front end and the back end, meaning on the software and the hardware side. And they're truly the folks that, as you see, buying chips, buying cooling systems, buying power systems. And the really what changed in the last 2 years, 3 years is the amount of cooling that is necessary to cool these 1,000 megawatt data centers, which it's about 40% of the power that's needed. So the chillers that we're assembling and integrating in our factories in Jacksonville and very soon in Texas, they're really that's what the power is needed for, is to run these huge chillers, which for those that are familiar with power generators, if you look at a 300 megawatt generator, that's about the size physically of a chiller that we're integrating in these cooling systems. So these are massive Legos that we build inside our factory. We deploy them to the construction sites. And when we modularize them in these buildings, we're able to take years of what used to take 2 years to build a data center. They're building them in 6 months, which is why they want the power so quickly.
So
You
I just
hear
wanted
of bridge power and other things. That's because we can provide power for some of these smaller modules as time comes.
So you mentioned Legos, which is a good analogy. But so like hyperscalers to the utilities, I mean, this is happening quickly. You said 2 years, but like within the 18 months of how they showed up at the door asking for the energy, I'm starting to understand the challenges of, requesting not only 100 megawatts, but now they're requesting 1,000, 2,000 megawatts, which
3,000, yeah,
besides
very.
almost the peak of, say, serving the city of Pittsburgh. So, there's this business model that, there's a lot of, I think, clickbait and headlines really driving less about what actually is happening. And I guess, it's how their business models up against the electric utilities business models, that demand is really redefining the relationship between utilities, regulators, and then the private developers. And so here's Stellar Energy. You guys were pivotal in serving that utility space with your, SME expertise with the generation. And what you said, and I don't think listeners may have understood, is what you did do is spin off an entity to really deliver and support really that collaboration that is now becoming much more privy to a larger amount of audiences. And we're talking 18 months here. So this is like new, right? Like the hyperscales energy demand is changing the grid shape from the way we plan transmission, how we plan local generation, really with the reliability standards and workforce requirements. So you very simply said that you built a manufacturing site in Jacksonville, Florida, right? So I guess I would love to hear, you identified a problem, you previously served solutions for those three, and then you effectively saw what was happening with this demand from hyperscalers and is changing the relationship with the utilities, which we could have a whole podcast or a whole series on. But what you have done is Stellar Energy, right? Is okay, well, there's a gap here. And so I guess talk a little bit more of how you were able to scale up such a product line to serve this new demand.
Yeah, I have to say that it truly, not just to give you too many plugs on AEIC, but the fact that you have such a cohort of both users, OEMs, engineering companies, and you have a platform to, one, put a hypothesis out there and said, what if we were to bring the hyperscalers to you and build the power plants and then transfer them to you and get live feedback in a way that we're not just looking for an angle. We're trying to understand, is this something that could work? And I think that that's truly the way that we were able to build so quickly. The way that we scale our manufacturing was in a partnership with another OEM. Baker Hughes had a facility in Florida that they were relocating to Texas. Like a good collaboration, we decided to roommate for about a year. We took half of the space and then eventually took over the entire factory. So I mean, I don't know of many industries that you can accomplish that, but kudos to both organizations on the Stellar Energy side and the Baker Hughes side, where they were building control valves for many of the OEMs, and we were building cooling systems for hyperscalers like Meta, Google, and others. And we did it live. I mean, we did it as the hyperscalers saw that we were able to scale up so quickly because we had a good network. It's all about time to first megawatt, Elizabeth. And that's the metric that I would say, I think for me, sees what a hyperscaler truly is looking for. For us in the power generation industry, we're always like, okay, what's the max efficiency you can get? Obviously, trying to minimize emissions and truly being true to energy transition. And then at the same time, how can you get a little bit more output and be cost effective? For them, they really didn't care what frame. They are very aware of that there's sustainability goals that we want to be able to achieve. But for them was all about time to first megawatt. How quickly can you get 1,000 megawatts on the ground? And they do want it to be reliable. They want guarantees of reliability. So I think that the partnerships with the utilities are critical. And I think to just speak a little bit more on to your point, the spinoff. So Stellar Energy is currently about 1,000 employees. We're going to go in about 1 million square feet, and it will continue to grow. We're going to have a very, very heavy focus in 2026, 27 on power generation and LNG. We're bringing on a new CEO. His name is Mike Vandermeid. He comes from Cheniere and Bechtel. He's going to be at the Charleston conference because we need to put heavy investments in this solution. Our data center team is also continuing to grow at just a crazy rate. But Stellar Energy decided to invest and is part of the creation of a company called Orion Digital Infrastructure that has successfully secured PPA contracts with some of the largest hyperscalers to build power generation for them and do it in a way that's it's extremely agile, and it could only happen with the ability to have close relationships with some of the OEMs and the engineering companies that we met during AEIC. Being part of this is not just the conference, your podcast, all the regional conferences, and that it allows you to have these conversations. And Department of Energy a lot of times is part of the conferences. That's also was able to hear on some of the proposals we've had. So that's what Orion Digital is about, and we're very excited about how collaborating gets us to where we are.
Well, I have one comment, one question, and then a tee up. But you do get the award for accolades to AEIC. And I love that you understand the objective of an organization. And I think, coming into this role of, focusing on how to support and create value for AEIC members that have truly been, some of them, members for 140 years, it's really refocusing the language that we use with others and the understanding that the space that we're in requires, like, going back to our roots of, like, really what created the machine that we have today, which is partnerships, collaboration, and sharing of knowledge. Sharing the knowledge of one is the knowledge for all. And
Yes.
in this space of massive amount of information, where does true intelligence lie? And it comes from experience that builds wisdom that then can be shared amongst each other, rinse and repeat. And, anyway, so thanks for the awareness of, the power of bringing those bright minds that are actively in it to really hear what their issues are, and then kind of developing the best practices and guidelines together as you go forward. Just a little bit, another hot topic that's occurring is, workforce development, right? And, what does that mean? It's, right now I think it's becoming really busy, but like in the end, we need people that can support not only the strategy, planning, and innovation side, but the construction, the doers, the developers, the ones with working with their hands. How has your organization really kind of upticked that capability to grow the team? I think you said a crazy amounts is especially
I
or on
think we
digital.
went from
What are
100 to
insights there?
1,000.
Right. So, what were
Yeah.
some of the programs or maybe kind of the vision that you all had to be able to scale that type of way?
I think before getting into like the actual, so we obviously needed, you've probably heard some leaders of different industries and organizations. I think Bill Gates and others have talked about the welders and electricians are truly the most valuable resource in the next decade. And I couldn't agree more. I mean, I think that for us, because we are in the integration of power systems and cooling systems, and we build these structures from scratch. I mean, we're buying steel, we're bending steel, on what in Jacksonville is a veteran town. We're hiring from as many as we can from that are leaving the Navy. We have an apprenticeship program that's extremely successful, and I think being part of local organizations, both government and trade, are critical for anybody that's growing. I think that's something that many of our listeners probably understand. I would say one thing, just getting a little vulnerable about at least a personal experience for me, and both when I spent 15 years with an OEM, and then as I joined this company as a CEO, and I brought a team to AIC. It's that there's so many people in our industry that are willing to be mentor, and I got so many mentors because I need them. They come from all types of different organizations, and they were all obviously all in different roles through their career. And I think to your point on institutions being members for 140 years, I know that I've seen the same leaders for the last 20 years at these conferences, and they've seen my personal growth, and they've taught me how to grow as a leader, as a scaler, and also they've helped me give feedback to my teammates and to my peers on what's really the let's not say the AIC standard, but the industry standard of how to lead and how to behave professionally, ethically, and make sure that we do the right thing. And I think that's important because that, the speed of trust is clarity and good communication. And in order for us to grow quickly and for people to trust that we can do this, we need to be clear on what we need. And I think that's been very important for us. So I truly just, it's been a very simple pick up the phone, send a text and saying, I need people in this part of Texas. I need people in this part of Jacksonville. Do you know anybody that's willing to partner? Where did you go? What companies did you use? And the help is there if you ask for it. We got help from the hyperscalers also on how they grew so quickly and how they helped some of their partners grow. And I think that's just a good practice that there's no secrets because there's plenty for everyone out there. You just got to make sure that you deliver.
Right. Well, I love so much there. Yeah, I've had many mentors, and actually in the class that I'm teaching, which was one of my original, like, why did I become what I, become in regards to being degreed, was to be a professor. And so here I'm living
Nice.
it. And not only am I
Yeah.
living it within the classroom at Carnegie Mellon, but now I'm like becoming and formulating really the language around the need for the mentor, the educator. And really, that is, in essence, the leader that we need. And sitting in all different seats, especially this very complex, as I like to say, the power grid is an ultra complex system, which is more than just complex. It's a computer science term. And I can't tell you how many times in all the conversations, and especially on this podcast, that it really comes down to the people that are involved and the trust and the understanding of each other's space, that kind of, for lack of a better word, the magic happens. So the advice that I was given over 20 years ago was pick up the phone, Elizabeth.
Yeah.
When I was a power system engineering consultant, and the beauty of that human connection, for that other person. And you're right, those mentors are still in the industry, and I still get to give them shout outs when I see them out there. Their words mattered at a really early stage. And just thinking, if we can do that to 9 or 12, just one person, right? What type of ripple effect if we're all in the right mindset? As you said, the speed of trust is very quick, and we need it more than ever, especially in the pivotal role that the utilities are playing with this new energy demand. And then we need the innovators and the partnerships and the collaboration of the vendor communities to really think of, those relationships and those engagements differently than maybe the last 40 or 50 years of where we've been. So I love it. Well, since I did bring up those students several times, I do like to wrap up these podcasts with really just any words of advice. And you kind of gave it, but that you would give a shout out to anyone that's entering this industry or looking to really identify where they want to spend their, next 20, 30 years in the workforce. Any last notes for our audience?
Yeah, I still, tell people that my favorite ever position when in a company or title was an intern. I entered the industry as an intern, and a lot of people at my former organization still say that, they I still sometimes act like one. And I think it's because I'm very curious and inquisitive. And I would say that it's so critical, and it's such a gift for you to be able to intern in different organizations and learn from different people. And then the other one, make sure that you take care of those who gave you a hand and put trust in you. I would always be grateful for the OEM where I spent 15 years. I am super grateful of the opportunity Stellar Energy provided and the entire ecosystem that brought in. And I think that's really important. And, outside of your salary and your title is make sure that you take care of those people that come through your path, because one day they truly will impact your future. And then at the same time, to give back, right? Make sure that you're providing feedback. My internship was given from another intern, and I gave my internship to 3 other interns. And that's the only way that how our power generation team and our entire industry is going to continue to grow. And the good thing is power is cool right now. Everybody's talking about power. Every conference that
Everyone's
you
talking
go,
about
they want to know about power generation. So it's a good place to be in.
I love it. So in the end, the grid does not just depend on circuits and generators and
Yes,
sensors. It depends on connection, the humankind. So I love it.
that's right.
Look where this took us. Okay. Well, thank you again for showing up, and I look forward to seeing you in 2 weeks at Charleston during our
Yes.
141st annual meeting. And I look forward to this journey that we're on together of transforming the energy space.
Likewise. See you in 2 weeks. Take care.
That's a wrap for this week's episode of the Grid Mod Pod. Thanks for tuning in. We hope today's conversation got you thinking about new and creative ways to improve our power grid. Be sure to subscribe to our YouTube channel to be the first to hear new episodes. This podcast is brought to you by AEIC, the place where operations leaders come together to share knowledge and provide guidance to the electric utility industry. We'll be back with a new episode soon. Until then, keep powering on.